Good afternoon to all of you. Yes, you can hear me now, Vinodini? Okay, good. So, I see good participation. No, audio is there, Gaurav? Audio is there now? I hope everybody has audio now. Okay. So, relax and enjoy this session. Okay, don't take it as a class. Just relax, listen to me, ask questions, and enjoy. Ah. Now, I'll be talking to you about big data technology. Ah. And what all it covers. You see, we use big data loosely. Ah, so I would like to cover this complete landscape. What all the subjects that are covered. Okay. इनको आंसर करते रहिए आप. He is not able to listen. Okay. So what all subjects does it cover? And when I cover them one by one, I will also describe how the technology works. Okay, how technology works. So at this moment, you can say that broadly, big data technology can be divided into, first of all, machine learning algorithm. That is the one subject that is an essential and first step of this. That is the essential and first step of this machine learning algorithms. Then you graduate to deep learning and natural language processing. Then the third subject is storage of big data. That there comes Hadoop, storing big data. That is comes Hadoop. And then I will be describing Kafka when I come later on. And I will also describe NoSQL and graph databases when I reach there. So my talk is divided broadly in these four parts. Okay. Let me start with explaining, first of all, how this technology works. When we say machine learning, all of you must have heard machine learning many times. So what does this mean? Let me take this mundane data of playing of golf, whether golf was played under certain weather conditions or not. There are four weather conditions: outlook, temperature, humidity, and windy. Whether it is windy or not. Okay. And then there is a target variable, whether golf was played or not played. Okay. Now outlook. Now for certain conditions in the past, I have the data. Given these weather conditions, golf was played. And given these weather conditions, golf was not played. For other weather conditions, I do not know. So I want to make a prediction. This is the weather condition, and please tell me whether golf would be played or not played. So these attributes which help in making predictions are known as predictors. In this case, the weather conditions, and what I want to predict is called target. So I want to predict whether golf is to be played or not played. So that is my target column, or it is also called class column. This data set is known as example data set or training data set. Training because I use this data now. I use this data and feed it into a software that is also called called algorithm. What the algorithm does is goes over this data again and again and tries to find patterns in the data. Given these weather conditions, for example, it says that rainy, hot, high and false, windy is false, humidity is high, then it says that most likely the golf would not be played, and for certain other weather conditions the golf would be played. The job of this algorithm is to search for patterns which lead to playing of golf and search for those patterns which lead to not playing of golf. it is possible that in a certain weather condition, golf was played, and in the same weather condition, golf was also not played. It is possible. So when it finds the patterns, it will tell me that given this pattern, there is an 80% chance golf would be played, and there is a 20% chance that golf would not be played. So it gives me a probabilistic estimate. Okay. So the job of the machine learning algorithm is to find patterns in the data. The job of machine learning algorithm is to find please note one thing. This is not a numerical data where I build an equation. This is not a numeric data where I build an equation and a into x plus b into y plus c into z is equal to golf played. Okay, it is not a numerical data. Okay, so now take an example. Now take an example which is more closer to an industry. I have put here two data sets. One is a data set from a Portuguese bank. This is a the Portuguese bank has, the problem is this: the Portuguese bank has devised a marketing product, a financial product. Okay, Portuguese bank has devised a financial product, and it wants to target only those customers which are likely to purchase the product. Say it has created a new kind of term deposit. And it would like to not to send email to everybody, not to ring up everybody and create nuisance. A bank has many lakhs of customers. Okay, so I will not send emails or ring up everybody blindly. I would like to know which customers are more likely to purchase and which customers are not likely to purchase. So how do I find out? This? In the past, a similar term deposit, a financial instrument was created, and the bank has the data for that. The bank has data for its clients, a lot of data is for its clients. What is his age? For example, 44. What is the job category? He is a manager. What is his marital status, education, and so on. And then it has also a data from its past experience whether he purchased the financial product at that time, one or no. So this is my target column, and this is my data about each client. This is my data about each client, and this is my target column. Now what do? I feed this data. A huge data is there. I feed this data into an algorithm. And that algorithm, you see, this, as I said, this is a actual data from a Portuguese bank, and this data has many other columns, and I am not able to show them because there is limitation of space. Okay, So the columns can be 50, 100. Columns can be many. So I feed this data into an algorithm, and the algorithm tries to find patterns that a person with this age, say age of 47, or in this age range, in these job categories, having these kinds of degrees, having this kind of balance, is likely to purchase the product, and another pattern of persons who are not likely to purchase the product. So once that model is ready of patterns, I feed my data of all my customers to this model, and then predictions are made who is the person, or who is the customer who is likely to purchase and who is not likely to purchase, and then I can target accordingly. Consider another example from human resource. You see, human resource, especially professionals who are skilled in their job, are important to any organization. and no organization would like that such people leave it, because if they leave, the costs are heavy. The costs are very heavy, and okay. So so the head of the organization, his chief executive, would like to know what are the threats. You see, nobody tells till the last moment that he is resigning, and once he submits a resignation, that decision generally is final. That decision generally is final. Okay, so then person goes. So even before he has submitted his resignation, I would like to know what are the threats so that I can take preventive action, remedial action to stop that person from leaving the organization. So how do I do it? Same pattern finding. The human resource has got lots of data for every person in its organization. But how satisfied that person, the employee is, what was his last evaluation score by his senior, how many projects he has handled, what is average monthly work. This data is from IBM. Years in company, whether he has faced any accident, promotion in last 5 years, which department he is working, what is his salary, and there are other columns which I am not able to display here. Last column is from the organization's data, whether this person has left or is still continuing. 1 or 0. 0 means he is still there, 1 means he is left. So given this training data, given this example data, again I run it through an algorithm, try to build patterns in it, try to build patterns that will help me make predictions, or try to build a model that will help me make prediction as to which employee is about to leave. Once model is built, then I feed the data of all employees, and it tells me that this employee may leave with a 70% chance, or may not leave with a 70% chance. So I can take preventive action accordingly. Maybe give him promotion, maybe give him good posting. Okay. Let me take this. Let me take an example from totally different domain. Okay, because data is everywhere. So from Africa's soil property problem. The problem was like this. You see, Africa is a large continent. Okay, Africa is a large continent, and much of it is desert. So the people there would be like to know at what crops can be grown in what soil, and in various seasons, so that accordingly accordingly land can be made use of for growing crops, and farmers can be advised accordingly. Now finding out soil properties is finding out what soil has what properties is like this. You go to a village, collect soil samples from there, bring it back to lab, analyze its chemical properties, and then say these crops can be grown in this season. But Africa being a very large continent, and there may be huge number of villages, so this is a very resource intensive job, time consuming job. So can I shorten this process? Can I shorten this process in some way? So consider this innovation and this creativity of a few people, what they did using this big data technology. Infrared rays were broadcasted on the land. Okay, when these rays get reflected, back, they are absorbed in various strengths across frequency band. For some frequency band, there is more absorption. For some frequency band, there is less absorption. So in various frequency bands, there is a absorption of these infrared rays in various strengths. These reflected infrared were again collected back by the satellite. They were broadcasted by satellite, reflected on the land, returned back, and collected by the satellite. So the satellite analyzed how much was the absorption across various frequency bands. There were 4,000 frequency bands. 4,000 frequency bands. They have been named arbitrarily like this, M7497. These are the various frequency bands. And there are 4,000 of them. 4,000 of them. And there is the absorption. 30%, 27%, 25%, 17% like this. Of various across frequency bands. Okay. Now, for certain soils in the past, I already have analyzed data in the lab. So for those soils, I know the absorption strength across frequency band, and I also know what soil characteristics it has got. How much of calcium, how much of phosphorus, how much of what is acidic strength, how much of carbon, and how much of sand. So, which means that for these 10, to say, as give an example on my screen, for these 10, I have the corresponding soil characteristics also. So, I have an example data ready. Please note one thing in this example. In this example, my target to predict are not one, as in the case of golf, as in the case of financial, to whom to target in the marketing example, or in the case of HR, who will leave. My targets here are 5. How much is the calcium? How much is the phosphorus? How much is the carbon content? How much is the sand? How much is the acidic strength? So there can be more than one targets for prediction in the same problem. So given this example data and with these targets, I feed this data into my computer algorithm, and then algorithm tries to find out patterns that for these absorption strength across frequency band, the likely calcium content would be this much, phosphorus content would be this much, carbon content would be this much, and so on. So once my model is ready, then from anywhere in Africa, I have this data for that particular soil. I feed it into the soil, into the model, and determine the levels of these constituents. Okay. So that is how this soil was analyzed in the continent of Africa. Consider now another example of e-commerce portal. You see, in a departmental store, offline, brick and mortar store, when a customer walks through the store, the sales manager is observing him. From what all routes he is taking to the departmental store, before which rack this man is stopping, customer is stopping, or what items he is touching. And then salesman can also talk to this person, his customer, and ask him certain questions. And not only he can get the answers from that customer, he can also judge from his facial expressions, the depth of his feeling, and accordingly take a decision regarding the layouts or regarding the preference for products. Consider now an e-commerce portal. On an e-commerce portal, senses do not work. I have no way to see a customer. I have no way to hear him or no way to talk to him. So how do I judge my layout of the portal that it is good? How do I judge whether my layout, as I do it in a departmental store, I lay out my departmental store, how do I judge it, whether it is okay for the customer or not? Now a lot of data is collected. From where this person came, what is his IP address? on which page he landed on my website. Which page he landed on my website. At what time he landed on my website. Which browser he used to come on my website. Which smart device he has used to come on my website. Which pages he flipped through. Click one by one. On each page, how much time did he spend? Did he click a video? If he clicked a video, how much of video did he see? Did he enter item in his shopping cart? If yes, which item he entered and which item then he also took out? From which page did he leave? All this data. For every customer who is landing on my website, I am collecting a huge amount of data. 24 hours, 7 days a week. And it is this data that I start analyzing to understand customer behavior, to understand his preferences and to know whether the layout of my store is okay or not. On internet, where sensors do not work, there is absolutely no option, or you can say there is one and only one option to use analytics to understand my clients. Okay, so this is another example of analyzing big data. If you have any questions, you can please go on asking me. There's absolutely no problem. Okay, anywhere, if any clarification is required, you can ask me. Okay. Now let me come to this. I've been talking of pattern finding algorithms. Pattern finding algorithm. Now consider this square. Okay, consider this square. Now suppose I have to find pattern in this. So one may find pattern row wise. There's difference of 1 here. Okay, one may find patterns column wise. Here 10, difference of 10 is here. Another way to find pattern would be diagonal wise. So what I am coming to it, there is no one way of finding patterns. There is no one way of finding patterns in data. There are as many ideas as there are people. There are as many ideas to find patterns as there are people. Or there are a huge number of algorithms to find pattern. I have listed a few algorithms here, decision trees, random forest. You need not go into this. My emphasis is here. There are a huge number of algorithms to find patterns, and studying these algorithms, how patterns are found out, and how using a particular algorithm and a particular data set, I develop a model that is the subject of machine learning. The subject of machine learning is to understand first conceptually how a pattern finding algorithm works conceptually, not mathematically, just conceptually how it works. Just as I explained to you conceptually how a pattern finding algorithm works, and then use it practically on data set and build a model. Okay, so that is the subject of machine learning. Incidentally, why it is called machine learning? Why word machine is used? It is like this. You see, if I have to find pattern in the data, I must go over the data again and again. I go data once, so I must go over the data again and again like a machine. Only when I have gone over the data 100 times, 500 times, then only then I am able to find patterns. Okay, so that is why it is called machine learning, because like a machine I am going over the data, iterating over the data again and again. Okay. Each algorithm has got a number of knobs. You see, like a pilot's cockpit, to fly a aeroplane, he has got a number of knobs. Okay, he uses them so that the flight goes smoothly. Flight progresses smoothly depending upon the weather conditions. Similarly, Each algorithm has a number of parameters, so to say, to set their values, to tune. For example, how many iterations? I can say 1000. Somebody will say 5000 iterations. So why 1000? Why not 5000? Somebody will say 10,000. So how many times it goes? And how many columns should I take? How many columns? 20, 30, 40, 50, 100, 200. So there are a number of parameters, and the view is something like a cockpit of a pilot. So machine learning also deals with how to fine tune these parameters, how to use these knobs so as to make as better a prediction as possible. So that data scientist is good. That data scientist is good, who not only knows his tools, that is the algorithms, but he also knows how to use them, how to fine tune his model using various parameters so as to make good prediction. Using algorithms, you see, as you join this course, and using algorithms is a 5-minute job, 10-minute job maximum. Code is very simple. 10-minute job, and an algorithm is there, and you start feeding data into this, and prediction is made. But the challenge is in fine tuning your predictions. I am not satisfied with 70% accuracy rate. I want 80%. And higher the accuracy you reach, the more fine tuning is needed. After 80, 82 is difficult. Okay. So optimization techniques are a part of machine learning. Now let me come to the subject of deep learning. Before I start with deep learning, I would like to have any questions from you on machine learning part before I proceed to deep learning. Any questions you have on this part, on what I have covered? Sample size, correct. Good question. I will answer them. I will answer it. Sample size. You see, generally, your data should be reasonably large. Your data should be reasonably large. Now, reasonably large, that is, you can say that around 2000 observations must be there. Around 2000 observations must be there. That machine is able to find. You see, the thing is like this, Ganesh. The thing is like this. You want to find good patterns. The more the data, the better the pattern. So if you have less data, pattern finding may fall, because then you may introduce some data which it has not learned. So generally 2000 depends upon number of columns also. Okay. So let us say around 2000 would be okay. Engineering. Now let me answer. What is the scope of machine learning? I will come to Avinash to this question. Scope of machine learning. My single word answer, Avinash, is wherever there is large data. You see, the thing is this. Today everybody is collecting data. Archaeologists are collecting data. Astronomers are collecting data. Wherever there is a large data and you want to make certain kind of predictions, machine learning is there. Wherever there, for example, archaeologists would know. Archaeologists would like to know where, given the present, they have made some discovery of certain artifacts. They would like to know in which other geographical region such artifacts can be discovered. Okay, so if they have data, example data, they can make that kind of prediction. So wherever there is a data, there is machine learning. Now, Lokesh, can it be used for engineering calculations? I will come to that just now when I talk about deep learning. Machine learning, you see, machine learning is learning about, you see, I do not want, at this moment, I do not want to give a very mathematical definition. I would only say that machine learning is developing a model to make predictions. Okay, developing a model to make predictions. related with statistics. Mohammed, I will answer your question related with statistics at the end of this. Okay, so related with statistics, that I will answer at the end. Career in ML, machine learning, Amit, I answered just now that question. Wherever there is data, there is machine learning, and now data scientists are large in demand. I will answer these questions, general questions, specifically a little later. No, we use now normal programming languages. We use Python. We use Python nowadays for developing algorithm. That's a normal language, I suppose, Avinash. Okay, I am coming to this AI. I will come that. Ganesh, I will answer your question. Chetan, that question, your question is quite specific. I cannot. You see, you choose. I will answer in one sentence. You choose that algorithm which gives me better accuracy. Okay. If you want to classify one answer, there are many answers to that. You choose that algorithm which gives you better accuracy. Basic algorithm list I had just now given, but I do not want to get into detail. Somdeep, I have given you these algorithms. This is a list. Okay, the top good algorithms. Geeta, yes. You see, big data. Machine learning is used on big data. I have big data, and that data I use to make predictions. Okay, Geeta. I have that big data, and I use machine learning to make predictions on that big data. All right. Now let me come to deep learning, and then I will come back some of the questions I have left. I will. Yes. Now please hold on. Now I will answer other questions a little later. I will answer little questions a little later. Okay. Please hold on. Please hold on. Okay. Let me come to deep learning now. Deep learning deals with a special class of data. A special class of data. Or as I think Avinash asked the question, how much data? Deep learning requires very large amount of data. Very large amount of data. Unlike the machine learning part that I was talking about, or I can say traditional machine learning, which doesn't require as much data. Machine learning deals with, for example, image classification. Can I say that this image is of dog? Can I say this image is of cow? You see, what I do is I put an image on a website. I put an image on a repository. Okay. The repository automatically classifies it that this is a cow's image, and then puts it under cow category, or this is a dog's image and puts it in the dog's category. Or it sees that image and says that there is a boy in this, text that boy in this, there is a bicycle in this, and there is a house in this. So it puts that image into house category also. Automatically, it puts that image into children category also, and it puts that image into bicycles category also. So this is a job of deep learning. Classification of images, tagging each object in an image is a job of machine learning. Then you have video frames. Can I predict the next frame? Or can I construct the next frame given the past frames? Given the past frames, can I construct the next frame? Job of machine learning. Can I create new music? Job of machine learning. How do I translate from French to Hindi or Hindi to French? Job of deep learning, sorry. And I think somebody asked the question regarding engines, the one question, how to use it in engineering. How to use it in engineering. This is an example from engineering. I have an assembly line, and you see today every person, even if he owns a car, he does it servicing regularly. So servicing is a part of maintenance, so that no breakdown occurs in future. Nevertheless, breakdown can still occur. A washer may fail. A small washer, which is not a part of regular servicing, may fail. Can I make a prediction in advance that this washer is about to fail. This is called preventive maintenance. If I am able to do that, I will replace that washer even before the noise starts coming in from that particular machine. So in an assembly line, I have a number of sensors and I note down reading from each sensor regularly. I analyze it, and even before regular servicing is being done, that is a separate issue. But even before a part is about to fail, whether minor or major, I take remedial action. So this is called preventive maintenance, and very important job of deep learning. Very important job of deep learning. How the technology works now. Let me come to how the technology works. Okay. How is it different from traditional machine learning? You see, learning is here also. Yes, telecom sector, Aditya, very correct. I said, wherever there is data, there is machine learning. I will explain. You have given a very good example, Aditya. Please hold it on. Please hold it. I will explain how it is used in telecom sector. Just hold on. You remind me later on if I don't answer that. Okay. I will answer your question. Now, how the deep learning is done? Okay. Deep learning is also machine learning. Why? In machine learning, I have data and I learn the patterns. In deep learning, also I have the data and my algorithm learns the pattern. This pattern is of rose. This pattern is of car. This pattern is of cow. So it learns the pattern. So pattern learning is also involved in deep learning. So that way, deep learning is a subset of machine learning. But then there is a distinction. There is a distinction. In deep learning, now consider for example this image. Consider for example this image. So what the deep learning technology would do is give a value to each pixel in this image. Each pixel is in this image. I will come to that. Okay, Ayush, please hold on. Let me explain. Then I will come to general questions. Okay, then I will come to general questions. Please hold on. Okay, I am not running away from this place until I answer your questions. Please be assured, I will not leave this place till I answer your questions. Okay. Okay. So, you know that every image is composed of pixels. Okay. And every pixel has a intensity, color intensity value. So, in this case, I have the color intensities of various pixels. So, first thing that is done is the image is coded into how much the intensity of pixels. Okay, it varies from 0 to 256. 0 to 256. Okay, so this is the image. You can say this is my image. Okay, now for a gray and white, for a black and white, I have only one square. But for a colored image, every color has three components: RGB. Red, green and blue. So for every pixel, I have its red value, how much of red is there, how much of green is there, and how much of blue is there. So now I have, for this image, I have now not one square of pixel intensities, I have three squares of pixel intensities. So to say, it is a three-dimensional data that I am having. Unlike the data in the case of bank, where for each client I had one row, its job, salary, age, and so on. Here for each image, I have this three-dimensional data. So data for each image is quite huge. And pixels, if it is 100 by 100 pixels, there will be 10,000 such data points. Because for each pixel I am having the data, so there will be 10,000 such squares, 10,000 data points. Okay, huge data. So the deep learning algorithm takes this data and finds pattern in them, how much of R, how much of G, and how much of B. Okay, that is the one thing it does. So that is one difference in deep learning and in normal tabular machine learning. But the major difference comes here. I'll explain the major difference in deep learning and in traditional machine learning. This is the same data which we discussed earlier, of which client will purchase a particular product and financial product, and which client would not purchase a financial product. Same data. And in the earlier data, I had drawn your attention to the age. That age were numbers, 28, 25, 27, like this. Age were numbers. Now, a domain expert who is good in banking, he would say, अगर उम्र 28 है या 28.1 है, it hardly matters. Whether age is 28 or 28.1, it hardly matters. Whether age is 28 or 29, it doesn't matter. What matters is whether that person is young, middle-aged, or senior citizen. That is what matters. He knows from his experience that is what matters. So he has transformed, that the domain expert has transformed that data to this. Middle age, young age, senior citizen, like this. So this column has been transformed. That is the first thing he has done. Numerical column can stay, no problem. My space is limited, I can't display everything. So numerical column can stay also alongside, no problem. But I will have this column also. Next, this domain expert says that even if a person is young, see his education. If he is an illiterate, then he will not understand my term deposit. He will not purchase. No young person who is illiterate will purchase my term deposit. So, and if a person is young and postgraduate, he is likely to purchase. So make a distinction between young and illiterate and young and postgraduate. So what it does is creates a column like this, which is a combination of age and education, middle age and postgraduate, young graduate, young undergraduate, like this. So it creates a third column like this. So what the domain expert is now doing, from his experience, he is creating new features that will help the machine to find out patterns quickly and accurately. The job of a domain expert is to create those features. Consider, for example, this example. If I am not a domain expert, if I am a layman, और हमने इसमें जो है umbrella sales का data भी डाल दिया, that this client purchased this colored umbrella, his umbrella size is this, and his umbrella price is this. So that there are another 3 columns in this data set. So that data is useless, and it will misguide the machine learning algorithm. It will misguide the machine learning algorithm in making this prediction. So the data which is here is important. What columns I am putting? So the job of domain expert therefore is to create those features which will help the machine learning algorithm to make better prediction and as early as possible. Now what does the deep learning do? Deep learning takes over this job of feature creation itself. It doesn't, hold on, deep learning does not leave it to the domain expert to create features. Deep learning does not leave it to the domain expert to create features. The creation of new features is integrally tied into the deep learning process. So there are a series of layers in deep learning which create new features, and after those features have been created, I feed it into the normal machine learning algorithm to make classification. Is the difference clear between deep learning and traditional machine learning? Yes or no? Is the difference clear? No. You see, no. I'll come back here. This part is okay. New features will help making better prediction. This part is okay. Okay. Now, deep learning consists of a number of layers. Layer 1, layer 2, layer 3, layer 4, where data passes through, and new features are created as data passes through, I am not constrained to these 1, 2, 3, 4, 5, 6, 10 columns. I am not constrained to these 10 columns. But deep learning would do is multiply 10 column or divide something by something. Okay, or add up some columns. It will create new features that help in making better prediction. So that is one of the ingrained process in deep learning, creation of new features, which is absent in a traditional machine learning. I am dependent upon the domain expert to create new features. In deep learning, that job is taken over by the machine itself. So in deep learning, we'll create this feature, for example, 8% education by itself. Exactly. That is why this deep learning is generally known as by artificial. You have hit the nail on the head. That is why this deep learning is generally known as artificial intelligence. It knows which features are good enough for making predictions. Okay. So the difference is clear, Geeta, Kaveri? You see, I am not going into the details how the features are created. Okay, that is that I cannot go in this short session. All right. Okay. So let me now come to the yes, Vijay, absolutely. Domain expertise is replaced by machine. Absolutely correct. The domain expertise is being replaced by the machine intelligence. Absolutely, 100% correct. 100% correct. So I have listed a few applications of deep learning. Start with image classification, image tagging, video frame prediction, new image generation with different styles, sentiment analysis. Okay, whether it is positive sentiment on a Twitter, negative sentiment on a Twitter. This is a field of natural language processing. I am not going into natural language processing here for the shortage of time. Okay, then clustering documents. For example, I want you see Google News, for example, clusters when you go to Google, if you are any news site, it clusters news items. Okay, sports news are in one category, celebrity news are in another category. Okay, political news are in another category. How it is done? No individual does it. It's a huge job. Okay, so this is done automatically. Two things are done. Ayush. Two things are done. One, as you read Google News daily, Google learns your taste. Okay, that you like, for example, political news, or you like sports news, and in sport news you like cricket. So Google learns your taste slowly. That is the one thing it does. And after it learns those tastes, it also tries to give that kind of news to you. So two things are done. So when it tries to give you that kind of news to you, it also clusters them intelligently. Sports news at one place, cricket news, among sports also, baseball in one place, cricket in another place, football in another place. So that is the job of deep learning. So Google uses all news sites, portals use deep learning to cluster news and give the news to you as per your taste. So that is clustering documents. Okay. Then speech translation, very common nowadays, and real-time speech translation. Google supervised by us meaning? No, I'm talking of any news portal. I'm not talking of Google only. I'm talking of any news portal. Okay, any news portal, NDTV or whatever news portal you are reading regularly. Okay, you will find that nobody does it manually. Gives you the collection manually. For prediction, yes. So predictions are made as per your initially when you open the site for the first time. It will give you popular news item in that particular category. Say political popular, sports popular, because it doesn't know you. First time popular. But as you go on reading, it starts judging your taste, and then it will give you news item specific to you, specific to your taste. Okay, that's called recommendation engine. All Amazon uses recommendation engines. Okay. Yes, correct, Satyabha. Deep learning is used in diagnosing abnormalities from medical images. Using lungs images, for example, pneumonia, cancer. Okay. And can detect deep learning can detect these images, the abnormalities, even though an expert doctor cannot. It can detect even minor things. Deep learning can detect even minor aberrations in images, which may miss the eye of a today busy doctor. All doctors are busy today. All good doctors are busy. So which may miss the eyes of a good doctor. Deep learning will tell you that this person has got some abnormalities in his medical image. Okay. So that is my general overview. Now somebody asked a question about big data. Up till now, I've been talking to you of machine learning and deep learning, keeping the volume of the data apart. I have not talked to you about volume of the data at this moment. Okay. But as you know, on a web, the data is huge. Facebook has huge data. Twitter has huge data. And any e-commerce portal where customers visit has huge data. So how do you store this data? First of all, you need to store this data, and then you need to analyze. Unless you not any internet data discussion forum, anything will not come on a single machine. It will not come on a single machine, on a server. 1 terabyte, 2 terabyte will not come. I will come, Kiran. I'll answer your questions. R can be used. R can be used. Okay. I'm Avinash. I'm coming to that. I'm answering that question only. Cloud means that is okay. That is what I'm saying. Coming to that. I'm coming to that only. I'm on that subject. Cloud only. So there are special technologies. There are special technologies to divide this data into chunk, spread them over various machines, okay, and analyze these data across the machines together. There are technologies to cut this data into chunks, spread them in various machines, and coordinate your task of analysis across the machines. It is just like an operating system. Just like an operating system takes the data from your hard disk, take the data from your hard disk, and then analyzes and then makes it available to various applications. Similarly, this technology stores the data instead of in one machine across the machines in various chunks, and coordinates the work of those machines as if they're a single unit, and presents them for analysis to any application that wants to analyze. You can say that this technology is like an operating system, like a Windows. In a Windows, the Windows gives the data of a hard disk to MS Word. It gives the data of the hard disk to MS Excel for analysis. Similarly, this technology spreads the data in various machines and then presents them from analysis to various applications that are there. This is known as Hadoop stack. Hadoop is a technology at the center of it. Hadoop is a technology at the center of it. You store data using Hadoop in various machines. And then you use other applications to read this data, to analyze that data. So there are applications to analyze data. Spark is one of them. Read the data, extract the data. Pig and Hive are there. So Pig and Hive are there. Okay. Then I'll come to Kafka separately. So this is server stack, and these are the applications that this the applications that run on Hadoop. So the machine learning job runs over this Hadoop. Machine learning job of analysis when the data is big runs over Hadoop. Is that part clear or no? Yes or no? You see, when I say machine learning, you analyze data, but where is the data? Charan, consider this. When I say machine learning, you analyze data. So where is the data? Where is the data? Not on a single machine. Not on a single machine. Data is spread over various machines. But data is huge. Data is in many terabytes. Data is huge. So how do you coordinate this work so that machine learning can run the algorithm? You see, machine learning job is to read the data again and again and find patterns. Its job is not to store data. So somebody has to give data to that algorithm. Somebody has to give data to algorithm in one piece. In one piece. This is the Hadoop is the means. Hadoop is a storage system. One of the storage system. There are others also. Hadoop is one of the storage. I'm only talking one. There are other storage systems also. Hadoop like data warehouse. Yes. Excluding Hadoop like data warehouse. So there is one storage with that one data warehouse which will present to my machine learning algorithm data so that it can analyze and build a model. Is that clear, Satyajit? Charan, is that part clear? Okay. Ambadas, is it okay? All right, thank you. Now, let me come to a very important subject. A very, very important subject. Streaming analytics. Okay, Anjali, I'll come back to Hadoop. Hadoop, you see that suppose data is your 10 terabytes. Can you store in a server, Anjali? Yes or no? Or let us say data is 100 terabyte. Can you store in one server? Yes. Shyam Sundar, there are alternatives. You see, I do not want to talk too many things. So there are alternatives. So you cannot store 100 terabyte in one machine. You have to cut it out. So there has to be system of spreading data. There has to be system of spreading data in various machines, and system of giving it to a application that will analyze it. Okay, some system has to be followed. Okay, so that's what Hadoop does. Hadoop stores data and then presents it to the application. Now you do your machine learning job. Spark does the machine learning job. You do your machine learning job, build models, find patterns, and give them to the customer. Okay. Let me come to a very Shamsundar, that is the example. You see, consider for example this Facebook site. Facebook analyzes data. Facebook has many hundreds of terabytes of data. Okay, yet it is able to recognize faces. So it is not that person's data would be stored in one machine. Okay, that person's data may be another machine whose face it is recognizing. So it is trying to bring data of that person which is in another machine and tell you that this person is Ashok Harnal. Facebook does it, na? Recognizes faces. Okay. All right. Let me come to this job. Real-time data. You see, many business models today are built on real-time analysis of data. Uber and Ola, for example. Are doing real-time analytics. Uber, for example, wants to, for Uber, whole city, every street in a city is a marketplace for Uber or Ola. Every street in a city is a marketplace. It wants to know, for example, which drivers are where, which drivers are not riding passengers, which drivers are busy, which customers are waiting, in which region there is more demand for taxis, in which region drivers are idle. So it wants to know, and If there are too much demands, what price should I demand? All this is in real time. All this is in real time. Uber cannot do batch kind of analysis. So this is a different branch of analytics. Analyzing data as it is coming in. For example, people are coming to my website on my e-commerce portal demanding certain product. So I want to know immediately which product is more in demand. Customers are coming from where? I want to know now before it is too late. How to cater for them. So there is a different kind of technology to analyze such kind of data. It uses Kafka at the heart of it. I had mentioned Kafka in the beginning. It uses Kafka and then does online analysis and then present them. So in our course it is there, streaming analytics is there. Again, consider this smart cities. Smart cities is nothing but real-time data analytics. For example, consider this example of smart cities. A car is entering a parking lot. A car is entering a parking lot, and so there are sensors in the parking lot. They will sense that car is coming, and it will indicate to that car that vacant spaces are available at this and this places. You can park your car there, and that man takes his car there. But there is no intelligence in this. It's only mechanical. This part is mechanical. The sensor in the parking lot senses it, that car is coming, and directs it to parking space. The smartness, the intelligence lies in the fact that given the choices, this man will always park his car at that place. So next time, this machine will keep a space vacant there for that person so that he can park his car there. Again, this is a part of streaming analytics and building, as I think somebody said, intelligence into machines. So streaming analytics is a totally different domain, and again handling big data, again handling large data. Huge data is coming in from all over the city. Huge data is coming in from all over the city. I need to analyze and take decisions. Okay. So totally different domain. Let me now come to my last part of this session, and then I will take your questions. Again, a totally different thing. Social network analysis. A network of friends, for example, on Facebook. Okay, network of friends, for example, on Facebook. Network exists there are many examples of network. Email networks are there. I correspond with some of them very frequently, some others not that frequently, but I do correspond. So there is a network of email friends, network of WhatsApp group. This network is there. Okay, road network is there. Okay, then telecommunication network. I think somebody was talking about telecommunication. Telecommunication network is there. So what kind of analysis do I carry out in this network? And these networks are huge. Network of professionals, doctors, network of lawyers. I carry out generally two kinds of analysis in this network. One, which nodes or which person, if I am dealing with person, is the most important person in this network. Yes, Piyush, I will give you. I will take questions just now. And please hold your questions. I will take it just now. But I am finishing and take your questions. I want to know which person is more important in this group. And importance can be from various points of view. Importance can be who is able to communicate or who is able to influence people. First is who is able to influence people, or who can spread rumors from that point of view. Okay, from the rumors that point of view. So I want to know which person is more important. That is one part. And then I would also like to know in this, what are the closely linked group? I will explain, Anjali. I will come back to your question once. Please hold on now. I am finishing. I am finishing. So I would like to know which are the very close group, which are the families, which are the political groups, which is the terrorist group, for example. Okay. So that is a job of social network analysis. This is handled through an application known as graph databases. Graph databases. And in our program, we covered that also. Okay. So that is what I wanted to speak about. Now I will take your questions one by one. I will take your questions one by one. I will start with Piyush. Apache and Pig, Apache Pig, Hive and Pig. In fact, what do they do? Data, as I start, just hold on. Okay, just please hold on. I will answer questions one by one. Okay. So you please wait, otherwise the screen scrolls. Apache and Pig, Pig and Hive, for example, are meant to extract data from Hadoop and present them to you. You can give queries on that data. Okay, give queries on their data. Which are my customers which purchase most? You can give that kind of queries on their data. Okay, so that can, and so Pig is used for that kind of job, extraction of data and presentation to you. Okay, next question. You see, business. You see, Sovik, business analytics is. You see, these things have many names. Many names. Business analytics, machine learning techniques, and big data are the same thing. And digital marketing, for example, I'll come back to digital marketing. Just please hold on now. Do not write any questions. Let me answer this first. Digital marketing. In digital marketing, you want to know the impact of your ad. You want to know where you should place your ad, for example. Okay, where you should place your ad. Which device, which domain, and what should be the cost of that kind of ad. So that is it, and what is the likelihood that it will be clicked. So that is the area of analytics. Now career opportunities, I have been talking, Shanku, that you see wherever there is a data, you see, okay, there is a, you see in times job and times career, you will find hundreds of opportunities. Okay. So now R versus Python. Python today is number 1, R is number 2. Python today is number 1, R is number 2. We cover both the languages. Karan. Okay. Yes. Can big data in all which language? Python. We will teach both Python and R. Now, which database is more concerned? You see now. Piyush, databases, there are a number of databases today. No single database. There is no single database. There are what are called is a category of database known as NoSQL databases. And there are a number of them. So I cannot answer that question. There are, for example, MongoDB database. There is Cassandra. Okay, there are a number, and okay. Hadoop use, you see, Amadas, it is like this. How do you store 100 terabyte? Tell me. How will you store 100 terabyte of data? Answer that question. Which machine will store 100 terabyte of data? So you need to divide that 100 terabyte in chunks. Hadoop will do it and store over various machines. That is the job of Hadoop. Storing data and presenting it to you. You see, our program, if you have science background, there is absolutely no problem. Programming language today are easy. They are not a hindrance at all. Programming language is not a hindrance at all today. They are very easy to learn. Yes, Anil Kumar, there are other applications which store massive amount of data. There are no SQL databases. Piyush, you are making a distinction SQL and NoSQL. NoSQL databases do not use SQL language. Okay, they use different languages. Okay, different way to access. Okay, and if you are from SQL background, so the ACID properties, if you know, they are not applicable to NoSQL databases. ACID properties, I'm not being a little more technical. Okay. Which source we use for data visualization? Which source means we have some number of libraries that is called. Lokesh, I will tell you one example from your this thing. A person came to me and he wanted to discover automatically scratches in automobile. He wanted to know which automobile has what scratches. Can I discover automatically using machine instead of seeing all the mobile myself, or all the automobile myself here and there? So that is one application. Then again, how to use the sensors, and make a how to use them and be able to make a prediction. Okay. Okay. I have given examples, for example, from the financial marketing. I have given example from how to which per customer should I target. To which, then I have given this e-commerce portal, how to understand customer behavior. That is correct, Piyush. That is correct. Absolutely. You see, many of our students are not only got a job, but are heading the deep learning units. Many of us, they're heading deep learning units about after this course. Okay, thank you, Lokesh. You see, the thing is, cloud computing also has machine learning. You see, the thing is like this, Anjali. You can, whatever you can do on your lab. You see, there's difference between learning mode and doing in production mode. Difference in learning mode and production. When you are in production mode, either you have a complete data center of your own to make predictions, or you go to cloud and hire the space from them and use machine learning there. Hire the space from some cloud provider and do machine learning there. So that is one option available for storing and analyzing your data. Another option is you have your own data center and put your data there and applying your machine learning algorithm there. You will learn this course gives you a complete overview. Complete all the components. How is machine learning works, how the deep learning works, how to store data. Complete overview. This is an online live course, live program. Just like I am talking to you just now, absolutely like this, step by step. I think Charan, then you can please talk to our Tech Mahindra officers. Okay, they will give you guidance in this. Okay. Genetic learning is used, Piyush, in tuning optimization. I talked about optimization. So genetic algorithms are used there. Okay, for optimization, which parameters to use for making best predictions. Okay, Piyush. Missed classes, recorded sessions are available. Hyperparameter tuning. Yes, you're correct, Piyush. Absolutely correct. This recorded sessions are available. Okay, no problem at all. Yes, I gave you an example. You can use it in for example, finding out, for example, what would be. You see, it is used in stock market predictions also. Okay, or where to invest, portfolio investment. It is used in portfolio investment. There are lots of exercises, Lokesh. Exercises are there. You see, our philosophy is very simple. Here, I am not to learn anything. It is you who have to learn. It is you who have spent the money and come to this course. So we want that you should be able to practice what we are teaching. Otherwise, there is no use. You see, unless you practice, exam no, but exercises many. And lots of stress on exercises by yourself. You have to upload data, Anjali, on the cloud. Yes, Somdeep, you can use in academic session. You can use, for example, which student is about to fare, which student may not fare better, which student may fare well, or okay, you can use like that. No, I'm talking to you just now. You see, and on our website, email is one means, and then our e-learning platform. I'll show you our e-learning platform. Just hold on. I'll show you our e-learning platform. Just please hold on. To show you what our students are doing. You see, these are all the exercises they are doing. And for example, I give them feedback 4 star, 3, 4 star, 5 star, 4 star. Okay, so that it is like this. So I am okay. So I am communicating with them. You can't see. Just hold on. Just hold on. Share my screen, come there. So you can see now, Lokesh, how I am communicating. These are the exercises. This exercises page. This exercises page for batch 4. Okay. So and I am giving the feedback through mail, and also I am on the page who are done exceptionally well. I am putting them with stars. 4 star persons, 4 star, 5 star. Okay. So I give the feedback like this. Okay, Shivam. Okay, then. See you, all of you. I had a good session from my point of view. Nowadays data is being collected by everybody. The machines everywhere, Piyush, and they are collecting data. There is no problem in collecting data in so far data is concerned. There is no sampling here. All data has to be taken. No sampling at all. No sampling. Whatever is there, you use it. Thank you, Shivam. Thank you. Thank you, Mrityunjay. Thank you, Lokesh. So long you are satisfied, I am also satisfied. Okay.